Okay, so in this session, we will look into one of the classifier. This is called decision tree. In the last session, you look into the perceptron, which is the one of the variant of neural network that can be used to perform classification. So this week we will look into another classifier. So this is called decision tree. So in trying to understand decision tree, we will try to illustrate the structure of the decision tree first, where we look at a few concepts here. So this is the root of the tree. Okay, we start from here, and we will follow the path depending on the value of each of the node that we have. So for example, in this node, in this root node, we consider the salary at least 50,000. If the answer is yes, we will go to the left. If the answer is no, we go to the right path. Okay, so for the decision tree, the leaf is considered as the class label. Okay, so this is the class label because we want to classify, kan? Okay, so when we have a series of logical decision, contohnya if we go salary at least 50,000, yes. Commute more than 1 hour, yes. So this is what we call a series of logical decision before we reach at the end of the branches, which is the leaf. Okay, so this is to make decision. Should I accept a new job offer? Okay, so this is a very simple example. If we go for more complex example, if we look at this diagram, okay, so we have two classes here. So the first one is the round blue circle, and the second one is the red square. So how do we separate them? So by using the decision tree, this structure, we would be able to classify them. So for example, this is the root node, x1 greater than w10. So greater than w10. And then if the answer is yes, so that means we go to another node. If the answer is no, so that means all of them belong to blue, okay, which is this area. And then in the second node, we check again if x2 is greater than w20. So w20 is this one. So if yes, then we say that they belong to red class. If no, they will belong to the blue class. So imagine that in the previous example, our aim was to draw a line that will separate the classes. But using decision tree, we will be able to draw a line that is not linear. Okay. So the definition of decision tree can be defined as two. The first one is the internal decision nodes. So for univariate means we are using single variable. So in this example, we are using single attribute, okay, single field or single variable. Okay, if we have two, like for example, x1 is greater than W10 and x2 is greater than W20. So this is multivariate, two variable. Okay, but for this example, this is univariate. So for the univariate, you could have the numerical value. So for example, this is your numerical value or discrete value. So this discrete value, something like this lah, yes and no. Okay, so for this one, we have two unique values, yes and no. So we have two branches going out from the root node. If we have n unique values, so we will have n branches lah. Okay, 1, 2, up to n. Okay, so that is for the discrete. Okay, so when we have more than one variable, so we call it multivariate. So we will use more than one attributes. Okay, so the leaf is considered the class label. Okay, or this is for the classification, but for regression, this is numeric values, which is the average. Remember that we performed the regression tree. So for the regression tree, we try to reduce um, the standard deviation when we want to split the tree. So this is can be applied in regression tree. Okay, so when we build the tree, the decision tree, we are using greedy algorithm in which we try to maximize the information gain or the entropy for each of the uh, branches that we have. So we will look into that one later on. Okay. Okay. So the decision tree are built using a heuristic algorithm called recursive partitioning. So if we have a few attribute or a few variable that we can consider, we will try to pick the best attribute that can split your data into two or more partitions that have the same classes, similar classes. Okay, so it uses the features value to split the data into smaller and smaller subset of similar classes. So what do? We use the best attribute that can split your data into subset of similar classes. Okay? So it will continue to split the data until all of your example at the node have same class. Means you do not have to go further down because you already have all the member in that particular node um, belong to the same class. Or you can stop if you do not have any remaining features to distinguish among the example in the same node. Or the tree has grown to a predefined size, like you want to have tree depth, like 3 times going down, or the width of the tree reaching the limit already. So we can stop the construction of the tree if the tree has grown to a predefined size limit. Okay. So this is a very important concept, sample entropy. So this is referring to how pure is your node. Okay. So for example, you have in one box. Okay. For the sample entropy, we consider positive and negative sample. Okay, so when we are here, because for the entropy we are looking at this one, this positive sample, when we are here, we assume that we have what? 0 positive sample. Okay. When we are here, we have 0.5. Okay, 0.5 meaning that we have 50 belong to positive and 50% belong to negative. So we have positive, positive, negative, negative, negative. So this is when we are here. Okay. When we are here, meaning that we have all the positive, so that means they are very pure. So we have positive, positive, positive. Okay. So when we are here, so here meaning that we have the entropy to be 1, okay, but your positive sample is 0, meaning all your member belong to negative. Okay. So this is the formula that we use in order to compute the purity of your node. So this is the probability of having positive sample. This is the probability of having negative sample. Okay. So this value will be positive value because this one will produce a negative value. This one will also produce a negative value. When we have this minus and minus, they will be neutralized. Okay. So how do we actually use this sample entropy? So sample entropy is used to measure the purity of your node, whether they belong to one symbol only, one class only, or a mixture of classes. Okay. So for each node that we have in our tree, we may have m samples of data that we have. Okay, and we could have this number of items that belong to class I. Okay, so the probability of having class I in this particular node is defined as how many of the member belong to that class divided by the size of your node. Okay, so for example, like this, we have the size of the node is 8. Okay, because we have 8 sample. And then the probability of having a class A will be 5 because we have 5A. And then the probability of having class B will be 3. Okay, so this value will be used to measure the purity of this node. So what is the formula? Okay. So the formula for the purity or impurity of the class is defined as this, which is the summation of all the probability of the classes. Okay, so for example, like this, we have 2 classes. So we will have 2 parts. So this is for the A and this is for the B. Okay, so when we plug in the value, then this value will turn out to be negative 4, negative 0.242, and then this one is negative 0.53. So when we add up the value, we have this. So notice that your impurity is high, meaning that not pure. You have a mixture of 2 classes here, 0.95. Okay, so if we look at the whole structure of the tree, for example, like this, suppose we have this table. Okay, so we have this class, whether we want to play or not, depending on the outlook, the temperature and humidity and wind. Okay. So this table has been analyzed. So we construct the tree. The tree looks like this. So this is the outlook, which is the root node of the tree. Okay. So we start from the outlook. We look at these values. So basically we have three unique values, sunny, overcast, and rain. Okay. So we want to know if we pick sunny, 1, 2, 3, 4, 5. So we have 5. So 3 of them belong to no and 2 belong to yes. So similar to the rain, if we pick rain, rain here, so we have 3 yeses and 4 nos. No, 2 nos. Okay, so similar to yes. Okay, for this one, for the overcast, we have 4 yeses. Okay, so how do we perform? How do we compute the total impurity for each of the nodes? So we will use the same formula here. So this is for the no, this is for the yes. Okay. So so we will have 3/5 and 2/5. Okay, for this one. Okay, similar to the overcast. The overcast we will have 4/4, because we only have one class, kan? Okay, so we can also perform this one, which is similar to this, because we have 3 and 2. Okay, so this is how we look at the table, and then how do we apply this decision tree to divide your data into partition. And then once we have the partition, we can compute um, the impurity of your data. Okay, okay. So in order for us to decide which attribute is best used to split your data, we must be able to compute the total impurity. So we have one portion here, the second one here. Let me use different color. Okay, so we need to join up. We need to join these values. Okay, so the entropy for this and this and this one. Okay, so for that reason, by computing the total entropy when we split the data using the outlook here, we can also compute the entropy when we split the data using temperature, humidity, and wind, and then we can pick the best one. Okay, so for us to join all the calculation of the entropy, so basically we are using the same formula again. Okay, and then we take the weightage, pemberat. Okay, so the weightage depends on the number of item that belong to the node divided by the number of uh, total of the whole sample. Okay, for example, like this. Let me. Oh, okay, so basically, this one is the formula that we use here. The calculation. This one. Okay, this one is the entropy for one node. So this is the entropy for one node because we are combining all the um, classes. Okay. So for us to find the best splitting, we have to know about information gain. So information gain tell us how important a given attribute of the feature vector is. So we will decide the ordering of attribute in the nodes of a decision tree. We can rank them. Okay? For example, like this. If we split the data over where the balance exceed 50K, so we will have this 4 and one here which is misclassified. Not misclassified, they are not belong to the same class. But if we split them over where the applicant is employed, so we can split the data into the round green and also the plus red. So this is better compared to this. So meaning that if we split the data based on the employment, unemployed and employed, we have a better partition of data. Okay. So impurity referring to not pure. Okay. So this one is a high level of impurity. So this one is pure because they belong to one class only. So this is very impure, meaning they are not pure compared to this one. This is minimum impurity, meaning very pure. Okay, you only have the green circle inside that partition. Okay, so to choose the best attribute to be used to split your data, so we will look into the info gain. So the info gain is basically computing the entropy before you split and after you split. Okay, so we want to know the differences before you split and after you split. Uh, we want to know the entropy differences. Okay, so for this one, for the entropy of the individual one, we can use the all formula. Okay, and this is the example. Okay, so this is the entropy for the sunny, which is this one, and this is the entropy for the overcast, which is this one. So this is 0.96, this is 0, and this is for the rain, it will be 0.96 as well. Okay? So to combine all these three, we have to use the weightage. So this one is coming from here, this one coming here, and then this value coming here. And then we use the weightage. So because we have 5 items here, and the total item here, we have 14. So we put 5 over 14. Over here is 4 over 14, 5 over 14. Then finally we have 0.94. Okay. No, 0.68. Okay. This is the entropy after you split the data using the outlook. Okay. Before you split the data, of course your data will be, let me erase this. Of course your data will be here. So basically before you split you have how many no? 1, 2, 3, 4, 5. So you have 5 no and 9 yes. Okay. So when we have this one, okay, how do we get this one? Basically, this one is the 5 over 14 log 2 5 over 14 plus 9 over 14 log 2 9 over 14, okay, minus. So this one will give you 0.94. Okay, so that is the initial entropy. So to know the information gain, so we want to deduct the entropy after you split from the initial entropy. So this is the information gain that we get, the value of information gain after we split the data using the outlook attribute. Okay, so we want to maximize this. So we will compare with the rest of the data lah. So next we will perform the temperature, humidity, and wind. So the one that will give you the highest information gain, then you will use that attribute to split your data or to become the root node of your decision tree. Okay. Any question? If you're okay, can you type number 1? Tidak banyak yang ni with me. Baru 15. Okay. So let me give you one more example here. Okay, let's suppose we have this data. We have this class label. Okay. We can split the data based on the count and also the total. Okay, but in this example, we are using the count here. Okay, so it depends on the unique value of your count here. So um, if we use the count, so basically we have 4 value kan? So we will have 4 lah. So this is for the A, this is for the B, C, and D. Okay, for the A we have 2 nodes, and for the B we have 2 no's and 1 yes. And then for the C, we have 3 yeses. And then for the D, we have 1 yes, 1 no. Okay. So the initial entropy will be 5 over 10 log 2 5 over 10. So this is for the no, and this is for the yes. Before we split, so before we split, we can compute the entropy based on this information. Then we get this value lah. Okay, so when we use the count attribute to split our data, then we can compute the entropy by computing individual entropy. Okay, and also the when we compute the overall, we have to take into consideration the weightage lah. So for this one, for the A, so this is for the A. So we have 2 over 2 log 2 2 over 2 because we have 2 A's, and the weightage will be 2 over 10 because we have only 2 item in this partition over 10. So we have 10 samples here. So similarly to B, so this is for the B, so this is for the no and yes, 3 over 10. And then for the C, so this is for the yes, we have 3. And then for the D, we have 1 yes and 1 no. And then in that partition, we only have 2. Okay, so this is the total entropy when we use the count attribute to split our data. Okay, so to compute the information gain, we take this initial entropy minus this. Okay, so this is the formula. Okay, the larger the value, the better is the feature is in relation to the class label. Okay, so we always look for the highest one. So for example, if the info gain for the count, this count is greater than info gain for this total, then feature count will be used to split your data first. Okay, because they are considered more relevant than the feature total in relation to the class label. Okay, so pay attention on this because you will be asked in the midterm. Okay, so this is the underlying task that will be performed when you want to construct the decision tree. But when you apply the decision tree to analyze your data, you will not see the whole process. But now, at least you know what's going on behind the process of decision tree. Okay, so now let's take a look at how actually we perform data analysis using the decision tree. Okay? So first we collect the data, and then we explore and prepare the data, and then of course in classification we need to divide the data into training and testing data set. Okay, and then we could evaluate the model performance, and then from there we learn how do we improve the performance of the model by having um, more trees. They call it random forest tree. Okay. Okay. The data that we have is loan application. So this can be obtained from this website. So this is how we read the data. So the data is stored in a comma separated vector. We read the data, and then we look at the structure of your data by typing str. So what we're looking here is that we want to look at this one, this one. Okay, the default, the default. Okay, the default means if the yes means they are not servicing the loan, means they are not paying the loan. If no means they still continue servicing the loan. Okay, so we have um, a few attributes here that can be used to um, learn this data. Okay, so you can use a few statement here. For example, a table can be used to look at the number of sample for each of the value that you have in your checking balance. So for example, like this, for less than zero Dutch money, okay, since this is Dutch money, we have 274 samples or records. Okay, for record that has greater than equal to greater than 200 Dutch money, we have 63 sample. We have 269 sample of record where the checking balance is between 1 to 200 Dutch money, and the rest is unknown, meaning this is missing data. Okay. We could also look at the saving balance by looking at the this column using the dollar sign. Okay. Okay, we could also use the descriptive statistics by typing the summary. The summary will give you what is the mean of the loan duration, what is the maximum, what is the mean, what is the median, what is the first quartile and third quartile. Okay, so we only can perform this summary for numerical value. So they will give you the descriptive statistics. Just a basic information about your data lah. So for this one, the loan amount is maximum is 18,420, minimum is 250. Okay. We can use the table statement in order to look at the number of item for each column. So for example, this one we look at the column default. So default yes means they're not paying the loan. So meaning that 30% of all time people don't pay the loan. So 30% of the population lah. Kan? Okay. So for that reason, if there is new applicant, they will look at the information. So based on those information, they can predict whether the new applicant can pay the loan or no. Okay, so now we will look at how do we split our data into training and testing. So over here we are performing sampling. From 1000 we only take 900. So we will select randomly. Okay, this set seed is used to fix the number that is generated randomly so that you can compare the performance later on. You can remove this one if you do not want to investigate further. Okay. So over here, based on the trend sample here, because we are looking at 900 sample, so we will select 900 from them from the credit, and the remaining, we have the minus here, meaning that the remaining of the sample will be treated as test dataset. So when we look at the proportional table of your credit trend, so basically you still reserve the distribution of the data. So similar to the test, you still have the more or less the number of no's and yes for the default value. So this is creating training and test dataset. Okay, now how do we apply the decision tree? So the latest one is most common use is called C 5.0. We can use this one by installing the package C50 and then load into the memory. Okay. So how do we use them? So we just call by stating C 5.0. We give them the training dataset. We give them the class label, and we say we only construct one table, no, one tree. Okay. So once we get the model, once we train the model, we will use them here, and then we will perform the prediction using the test dataset that we have. Okay. Then later on from this prediction, we can know the performance of the trees. Okay. So for this one, we will pass all the values except the column number 17, which is the default value, the default column. So we will only pass data from 1 to 16, and then the 17 we will remove lah. Okay, and we also pass the class label here. Okay, so when we type the credit model, the summary credit model, So we will have this kind of result that we get. So basically, we are saying that if your checking balance is greater than 200 Dutch money or unknown, then you will not likely to be defaulted. So this tell you how many sample that is correctly classified. This is incorrectly classified. Okay. So if you want to look at this area, so basically we are going to the first one is this, and then you go here 2, and then you go here 3, and then 4. So basically you have 4 combination of logical comparison. So first, the checking balance must be in this less than 0 or between 1 to 200, and then the credit history must be critical, good, or poor, and then the monthly loan duration must be less than or equal to 22. Then your credit history to be critical, then you are here, meaning that you will not be defaulted lah. Okay, so this is the statement that you can give to your client based on the three. You're saying that if the checking account is unknown or greater than 200 Dutch money, then classify as not likely to default. Otherwise, if the checking account balance is less than 0 Dutch money or between 1 and 200 Dutch money, and the credit history is perfect or very good, then classify as likely to default. So this one is this one. Okay. So decision tree is a very good classifier in which you can explain why certain sample can be classified as positive and negative. Okay. So how do we perform the evaluation? So we will look at the error here. Okay. For the training one, we have 900 cases and we have 133 cases, which is not correctly classified. So this is your error, which is 14.8. So your accuracy will be 85.2. Okay. So how do we improve the performance of this decision tree? Okay. This is during the training. So when we perform the prediction, we use the model and then the test, and then we plot the confusion matrix. So using the cross table here. So basically, this is the actual default. So predicted as no. So this is true positive. This is true negative. So the error that you get will be this. Okay. So for this one, we have 27 divided by 100. So this is your error, which is 27%. And your accuracy will be 733%. Okay. So based on the confusion matrix, this is true positive, this is true negative, and um, this is false negative, this is false positive. Okay, so we do not want to count this one. This is error, so we get 27 out of 100. Okay, so how do we perform the how do we improve the performance of the model? As you can see, you can create your tree in many ways. it depends on what attribute you use to split the data. So for that reason, for C.5, they can use this trial to be 10, in which you can create more trees. Okay, more trees. You perform a variety of um, construction of the tree, so you have variant of trees. Okay, so when you perform this, you are looking at 10 trees. Okay, so if you look at the performance here, so the performance here, the number of error has been reduced. So this is 18.100. So this is your error. Okay, 18%. So your accuracy will be 82%. Okay, so if you do work in machine learning, and also if you are looking at your FYP now, you may come across with random forest. So this is what we mention here when you are looking at random forest. Okay, random forest. So basically, they are decision tree with many option. Okay, so instead of one, you have 10 option here. Okay, 10 kind of trees. Okay, so in summary, today you learn how to partition your data in order to construct the tree. So we are looking at the entropy. This one you must know, must understand, because if you are dealing with data using machine learning, you have to look at this entropy. Okay, and also this entropy is used to compute the information gain. Okay? And we also look at how decision tree can be applied using the C5.0, and then how can we improve the performance of your classification. Okay, and we have shown that one in a real world classification task, such as identifying risky bank loan. Okay, this one we will go into for your assignment. Okay, so in your assignment, you'll be dealing with this data set in your practical number 5. Okay, thank you. Are you, are you still with me? If you are still with me, can you tap number 2? So as you can see, all my lecture is more or less around 40 to 50 minutes. So thank you for your time.